Period is how long it takes for it to start repeating. So, like here, it's a little cut off right here, but you can see it on this side. So, if we think about starting right here, whenever we go up and back down, and right here it would start repeating, right? It kind of got cut off, but we can look on this other side right here and see that was negative 2 pi right there to 0, so it looks like 2 pi is our period for this one. Let's see. All right, it looks like most everybody's answered that. Let's see what you guys put. Okay. There's several different answers. The one that looks like it's showing up the most is 3 sine x. Let's see, did anybody use cosine? I do have a cosine right here. Brittany used the cosine, but she's changing her mind there. So I think sine is going to be best. Why is sine best here? It starts right, it has a midline, a y-intercept right there at 0, which is the midline, right? So this one has not been moved up or down. I don't think anybody put anything where it's been moved up or down. I think that looks good. What is our amplitude? It's going to be 3. Amplitude is the distance from the midline to the highest point, and that is 3, which means that that 3 right there is correct. And let's see here. This has not been shifted to the left or right any, because the like right there, our y-intercept was on the midline. And has it been shifted up or down any? Still, my midline's still right there at 0. So why? Let's see if anybody's got it exactly like I want it. Oh gosh. This person, Srinivasa Ramanujan. This person has it exactly like I would like to see, where we've got the f of x equals, or you could put y equals instead of f of x. So that I would really like to see there. Let's look at what Radiat here has. Radiat has a 2 pi right there next to the x. Okay, why do you think they put it there? Because that is the period of the graph, right? But for period on a graph, it is 2 pi divided by the number in front of the x. So if we put a 2 pi there, then our period would be 2 pi over 2 pi, which would just be 1. So you don't put the period there. You put whatever number. If your period is 2 pi, you need the number that 2 pi divided by 1 is going to give you 2 pi, right? So it's the number that you're going to divide by. So you should not have any numbers in front of your x. So Wayne here has that 2 that should not be there. And no, it's 2 pi. Because, see right here, from 0 to pi, it's not done repeating yet, because you still got that negative portion of the graph. So you got to go the positive portion, negative portion, and then when you get back to that midline. There. Okay, questions? All right, go to this next one, and I want you to give me the equation for this graph. In fact, go ahead and do, well, let's do one at a time. V is super fast. Okay, I think we got everybody here. Let's see what we got. All right, I'm seeing cosines. I like that lots of you have either f of x equals or y equals. Some of you still do not have that. Okay, I see a 3 here for amplitude, 4 here, a 1 here, but most of you have a 2. Amplitude is going to be 2 because it is the distance from your midline, which is at -1, so you should have -1 here, to the maximum, so that looks good. What has Dorothy done wrong here? Dorothy, don't change it just yet. Okay, 2 pi is your period here, but you don't put that number there, okay? So if the period is 2 pi, you don't put anything in front of your x, so you would not include that. So the 2 cosine x minus 1 is correct. I don't think anybody used sine. Okay, could you use sine? If you really, really wanted to. You could. What would you have to do? You'd have to do a phase shift with sine, but you could use sine for this. But cosine's much easier to use. So if we see this, cosine is going to be the easier option. There. Okay. Questions? All right. So the period is how long it takes for the function to start repeating. So I usually, now on these my graphs are, if I had zoomed out just a little bit more on the graphs, but it kind of, it looks different whenever it shows up, so I probably had it wrong there. But, so like if I start right here at 0, that's a maximum point. So I'm thinking about how long it takes me to get back to another maximum point. It ran off of the graph just a little bit here. But if you look at it in this direction, you can see right there at 2 pi. So from -2 pi to 0, that's a distance of 2 pi. That is your period. So if the period is 2 pi, then you won't have anything in front of your x because it's just a 1. 2 pi over 1 is going to give you 2 pi. Okay? All right. Go ahead and do this next one. So for the period, it's how long it takes for the graph to repeat. So like on this one here, if you start 0 is typically your easiest place to start from. But if I start right here and then I go, see how far it takes me to get to the next maximum point, it's whatever that distance is. Or you could go from like minimum to minimum. So like -pi to +pi, that would be a distance of 2 pi there. Now, finding what number to put in the equation is a little bit different. Oops, I don't see that yet. Okay, let's look at these. All right, so, let's see, most everybody is cosine. A few of you are sine. Most of you do not have a number on the end, but a few of you have a +1 or a -1. I see a +0 here. What is the midline for this graph? It is 0. So the +0 is okay, but the +1 would not be correct. Most of you chose cosine. Sine can work, so I'll check the sines here in a second and see if they are correct. But cosine's the easiest because this one has a y-intercept at a maximum point. So that means if you use cosine, you don't have to shift it to the left or right any. And then I've got a 2x right here. This is correct because the period of this is pi right here. So if we're thinking about what number needs to be there, whenever you're thinking about this, you know it's going to be, you're going to have cosine of b times x, 2 pi over b. Has to give you the period, which is pi. And so what number should go there? 2 right there will just give you a pi if you put it there. So y equals cosine of 2x is correct. Let's go down here and see. I think everybody's changed theirs. Richard here has an amplitude of 2. Is that correct? Okay. What Richard might be doing, I don't know who Richard is, so I'm not certain about what Richard is thinking, but you might be looking at the distance from the highest point to the lowest point. Amplitude's just from the midline to the highest point. So it's going to be half of that. It's just going to be 1 for this one. Okay, questions? All right. Try this next one here, graph 4. More seconds on that. Everybody try something. Okay, this time do me a favor. I don't want anybody to change their answers until I tell you to change your answers, because sometimes we can learn a lot from what people do wrong. And I will not call you by your real name. I'll just call you whatever your fake name is, so nobody will even know that it's you. So whenever I show the answers, don't immediately change yours to match the one that's showing up the most, if there is one that's showing up the most. Okay, and then we'll let you change it afterwards. So I think we're going to have a little more variation on this one. I'm seeing sine and cosine almost evenly here. So there's a good reason for that also, because is this one clearly sine or cosine? It's not. So there's really not one that's better to use here, sine or cosine. You could use either one. So there's going to be a correct version of sine and a correct version of cosine. I guess there always is, but there's going to be, neither one's necessarily easier. So let's think about this graph. I want to know about the period of this graph. What is the period of this graph? It's 2 pi. Okay? So whenever you're looking at this, so it's not, period is not the distance from 0 to the maximum over here. It's how far it takes to start repeating. So like your y, if you want to start at 0 right here, you want to see when you hit that same height again, which would be right here. Or if you're thinking from maximum point to maximum point, this, it's not super easy to find, that's pi over 4. And this would be 2 pi plus a pi over 4. Right, so it's going to be like 9 pi over 4 or something. If you subtract those, you get 8 pi over 4, which is 2 pi. That might not be the easiest way to do it, but I like to start from 0 and just see when I get back to that same point, because then you don't have to worry about pi's over 4s and all of that stuff there. So period is 2 pi. So don't change it right now if that's not what you've got. But should we have any number in front of our x? No. So, like here, Gertrude it looks like Gertrude probably thought the period was 2 pi, right? But Gertrude, we do not put 2 pi here if it is the period, right? Because it's b, whenever you have cosine of b times x, it is 2 pi over b that is supposed to give us 2 pi. So the number right here is what we're dividing by, not the actual period there. So, so that'll be not correct. So we should not have anything in front of our x. So if we got a 3 right there, we won't have that in front of our x. We got a 2/3 right here, a -2. So don't change it yet, but we won't have that. And that's the same for sine or cosine, because that's just the periods are the same for both, right? All right, so then amplitude of this is just 1. Midline is here, so we should not have anything added to the end, which I don't think we have anything added to the end except for Gertrude, who's messing with hers a little bit. And we should have an amplitude of 1, which looks like everybody does. Wayne here actually put 1 there. Is that necessary? No, but doesn't hurt for it to be there. So that looks good. Now, what we're looking at here is whether you pick sine or cosine, you have to have a phase shift for this. So normally, if you start with cosine, let's think of cosine first. If you start with cosine, it normally would have a maximum point right here. But that has been shifted over this distance, which is halfway between 0 and pi. Half of a half is a 1/4, so it's pi over 4 right there. So if we shift to the right pi over 4, what do we have to do in our parentheses? Negative. So between Brittany and Etta here, Etta is the one correct because she has that minus right there. So for cosine, it would need to shift to the right pi over 4, which means you need a minus right there. Let's go down here and look at some of these that have sines. So sine, here I see sine plus pi over 4. That one has 1. It looks like some of my sine, you guys are changing them. Look, Nalini here, Joshi, you are changing it right now. So hold off on changing it just yet. All right, so if we use sine, so one correct answer is this one right here, cosine of x minus pi over 4. If we use sine, normally sine has hits at the y-intercept right here, or at the midline right here. So sine has been moved to the left pi over 4. So to move to the left pi over 4, we would do y equals sine of x plus pi over 4 for that one. So we wouldn't have this 2 right here. Possibly Thomas, what do we think Thomas might have been thinking there? That put a plus 2. I think Thomas probably was counting that that's 2 little blocks over and put a 2 there. I could be wrong. Don't know who Thomas is. I won't make Thomas speak up and reveal his identity there. But it is 2 blocks, but you got to look at how it's labeled here, so it would be pi over 4. Okay, questions? Yes. It's both. Both are correct. So y equals cosine of x minus pi over 4 is the same graph as y equals sine of x plus pi over 4. So they're identical. So either one is correct. So that's always the case, even with the ones we did before. If we went back to those other ones, we could write sine graphs for them also. or cosine. But the other ones had like an easier one to use because you didn't have to shift it left or right. Here, neither one of these are really easier than the other, so you could use either one. Whenever you'll see these questions, they will be multiple choice most of the time, or there'll be something that I'm grading by hand. If I'm grading it by hand, you could put either one, you'll get it right. You don't have to have them both. If it's multiple choice, only one of those answers would be there. So if you get cosine of x minus pi over 4, but it's not there, then think about what it would look like if it was sine. Okay. All right, questions? All righty. All right, so on the next slide, I want you to graph a sine function with the following characteristics. And I'll leave this up here on the screen so you don't have to flip back and forth. Amplitude of 3, period of pi over 2, midline is 0, there is no phase shift. Okay, so you have to go to the next slide to graph that because it won't let me put that information with the graph. You can type in on the slides. So I'll leave this up here and let me zoom in a little too. So you can see a little better. So do that for me on that next slide. Go to the summary real quick just to see how many answered. And this is one you can kind of play with on the graphs until you get one that's right. All right, let's see what we've got here. All right, so lots of these look the same. Sometimes the zoom can make a difference, but I think we're looking pretty good on amplitude. So for these, for your amplitude, you're going to have an amplitude of 3. So whether you used actually this one said a sine graph, didn't it? So you're using sine. You should have a 3 in front of it. And then I'm just going to click on, let's click on Mariel Vasquez here. This person has 3 sine of 4x, right? Midline is 0, amplitude is 3, period here is pi over 2. Okay? Remember, to find that period, we would do 2 pi divided by the number in front of our x right there, which is 4, which would give us pi over 2. So it looks like this is good. That's pretty, since it told you it had to be a sine graph, that's pretty much the only thing that you can do for this. So if you don't have that, you can go ahead and change it there. Actually, hold on. Let's see. Let me see if there's still one that's wrong, because don't change it if yours is the wrong one. I know you don't want. What do I need to do here? Wow, I need to put that. Let's look really quickly at this one. So notice what happened right here. This person right here, they put pi over 2 in before their x. That number does not go there. We do not put the period directly into the equation ever. So it's going to be 2 pi. Has to be divided by that number. So 2 pi divided by that number would not give you pi over 2. suspected that is what had happened there. Okay, questions on that one? Mm-hmm.
So why do you use sine instead of cosine?
The only reason you use sine instead of cosine is because it said to use sine. So it said graph a sine function. So that is the only reason. Yeah. Mm-hmm. Okay. All right. Let's go to the next one. Here. All right, so this one tells us, this one says on the next slide, graph a cosine function with the following characteristics. So we're using cosine this time. And we want an amplitude of 2, a period of 2 pi, a midline at 6, and a phase shift to the right pi over 4. So go to the next one and try to graph that one for me. All right, let's see what we've got here. Okay, zoom on this is different for a lot of people, which is why they look so different up here, but I bet if I click here for Brittany, that we've got 2 cosine of x minus pi over 4 plus 6. Let me go back over here to one that looks way different. Eta has the same equation, it's just zoomed in a little bit differently there. So amplitude has to be 2, you got to have a 2 right here. Midline has to be 6, you got to have plus 6 on the end. No number in front of your x because the period is 2 pi, that means it doesn't change. And the minus pi over 4, did it say which direction? Is that right? I've forgotten what the question was asking now. Phase shift right pi over 4, so it should be minus. Yes, that's correct. So this equation right here is definitely what you should have. Any questions about getting any of those pieces? All right. I think more or less we look good. It's a little hard to tell for sure with the zoom, but I think those look pretty good. Okay. The next one, you're going to do an amplitude of 1, a period of 4 pi, a midline at -3, and a phase shift to the right pi, 2 pi. So this one's a little tougher because it's got a period change and a phase shift. All right, let's see what we've got here. All right. several of these look similar. It's a little hard to tell with the graph. Let's just see what we have here. So for Thomas, amplitude of 1, so you should not have a number in front of your cosine. Or if you do, it should be 1. Midline at -3, so we got this -3 on the end. Does that look good? Okay, so when I see here that Thomas has x over 2, this is like having 1/2 times x. So that number in front of your x is 1/2. So the period would be 2 pi over 1/2, which would be 2 pi times 2 over 1, which is 4 pi. So I think that looks good. Yes? It is not wrong if you put 1/2 x. That's perfectly fine. But I will say that I'm kind of glad I clicked on Thomas's name here, because you're more likely to see it as x over 2 if it's given in an equation. So like on answer choices and different things, you're probably going to see it as x over 2. So know that if you have x over 2, it equals 1/2 x. And so phase shift, somebody remind me what we do to figure out the phase shift. Minus c over b, right? So c is this number right here, so we got -2 pi divided by 1/2. So that would be -2 pi times 2 over 1. What's this phase shift? -4 pi. Is that what we were supposed to have? Supposed to be 2 pi, wasn't it?
I just put in -2 pi.
Okay, we cannot just do that. Yeah. It works as long as your period has not changed. So like on the last problem here, for this problem, we had a phase shift pi over 4 to the right, and all of our equations just had a minus pi over 4, right? And that worked beautifully. But the reason that it worked is because we didn't have a period change here. So let's look at what we would do for this. And you might, I know we don't have like notes printed out, but you might want to jot this down here. So you can do this sort of playing with Desmos, or you can do it algebraically, which sometimes when you have a little bit more difficult numbers is a little bit easier to do. So we know we're going to have, for this is a cosine function, so y equals amplitude of 1 cosine of bx plus c. We know we're going to have -3 on the end. So when we're doing these, the amplitude and the midline should be your easiest pieces. But the middle is more difficult, especially if you have both the period change and a midline. So to find the number you need here for your period, to get the period, you always do 2 pi over b. In this case, we want 2 pi over b to equal 4 pi. Right? And so I could put that over 1. I could cross multiply. B times 4 pi equals 2 pi. And I could divide by 4 pi to get that b by itself, which means these pi's right here will cancel. And 2 over 4 is going to be 1/2. So I get b is 1/2 here. So I could take out that b right there. I could put a 1/2, or I could write it as x over 2, but we'll just leave it a 1/2 for right now. So we okay on finding that number for the period? You might be able to just do that in your head also. You might not have to set up the equation for it. But especially if you get something difficult, you might want to set up the equation. And I think you guys had some practice with this last night on the Delta Math. But what you didn't have on the Delta Math, because Delta Math doesn't include this, is phase shifts in with it. So with phase shifts, we know it's -c over b, which is 1/2, right? has to equal the phase shift. If it is right 2 pi, that's a positive 2 pi. So how do we solve that? Multiply both sides by the 1/2. It'll cancel there. Half of 2 is 1. So you got negative c equals 2 pi. I'm sorry, pi. So c is negative pi. So our equation here can be minus pi. Right there. So you can write it like this. You'll also see it a lot of times. They like to write this as x over 2 or theta over 2 minus pi minus 3. Okay, questions? All right, the last one we're going to do together is here. So on the next slide, an amplitude of 5, a period of 5, that is supposed to be 5, not 5 pi. It's a little weird, but it is what it's supposed to be. A midline at negative 3, and no phase shift. All right, let's see what we've got. All right, so I'm interested in Richard's here. Looks crazy. Let's see about it. Okay, Richard, and Richard may not have been finished. What was the midline supposed to be? I'm forgetting. Let me put it back. Midline's negative 3. So now Richard has his midline. Correct. So we need a minus 3 here. We need a 5 out here for our amplitude. That is correct. So let's see if Richard is correct on his period. So I do 2 pi divided by this inside, so that would be 10 pi. Pi's will cancel. What do I get for the period for Richard here? 1/5. So period is not correct on this one. Although we're getting a 5 somewhere, so that's good. All right. Let's go back. Yes. 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 And so let's check out Etta here. Etta's got 2 pi over 5. Let's check to see if she is right. So 2 pi divided by 2 pi over 5. Dividing fractions, easy as pie. Flip the second and multiply. 2 pi's cancel. We just get 5. So Etta looks like she has the correct graph here. As Mia was asking, what you can do there, especially on this one, because it's not so easy to like just off the top of your head come up with 2 pi over 5. You can do 2 pi divided by b has to equal 5. And so if you put that 5 over 1, you can cross multiply. 5b equals 2 pi and you can divide both sides by 5, which will give you that 2 pi over 5. One other thing that they might do here that might be confusing to you, they might write it like this: y equals 5 sine of 2 pi x over 5 minus 3. So that's just like they put that x over 1 and multiplied them together. So if you see that x in the numerator, it's the same as if it's over to the side. Okay, questions? Okay, so your assignment that you're going to work on right now is going to be, get this off. Get back here. It is going to be the other Desmo's classroom assignment that was there. So how do I get back to where I want to be? So it is going to be the one that says sine and cosine graph practice. And there are 6 there that you're going to do. And then there's also a worksheet, but I forgot to copy it, so I've got to go copy it real quick. Okay, so go ahead and work on this right now. Hopefully you'll finish it before you go. I'm going to cut the screen off. So. Well, it doesn't tell you whether it's right or not, does it? Okay, it just completes it. It tells me whether or not you got it right, but it does not use it. And then let me go run a copy of that worksheet that I forgot to copy. Okay. Also remember, what do we have tomorrow? Unit circle quiz. I will give you a blank unit circle, and you will have to fill it in. Let's see, I think I've got some. If you want some to practice, I've got these adorable, cutest thing you've ever seen in math, tiny unit circles. So I'll just leave them up here. If you want some just blank ones to practice with, you can grab a few of these here. Sine. Think about what your unit circle value is. Like right here would be like your pi over 2. Is it 1, like this one, or is it next one? Does that make sense? So what you need to do here is put a B there. If you're getting the right answers every time, you might be right. Quite well. What I usually do though is I just do 2 pi over b equals whatever the figure equals. So in this case it was 55, right? Right. And so like this side's always the same because you always do 2 pi over b. So then if it's a whole This way you'll get 5b equals, and then you're trying to find the b, right? Trying to get b by itself. So you're dividing both sides by 5, and then say your b is 2 pi over 5. Yeah, I think it is. The other thing is like you're rarely ever going to see anything like that. It's on top of the bottom. So yeah, so it's not. I think what you probably did is like you came up with like alpha score is the same. Yeah, like well you probably like saw the answers and like figured out how to do it without having to set up the equation, which you're kind of doing like that same stuff in your head. But you might want to stick with this just because it's not usually going to look like that. Yeah. Me too, Leslie. Me too.
I can do it.
Working every time is okay. The only thing is I don't like this time. Yeah, even though it is correct, I don't like it. Okay, so what we could do instead is that 5 up here, extend and make it a plus 5. I forgot to do one like this. What happens if you have a negative in front of the sign? If you're asked for midline or amplitude, you would take the absolute value. But what is it going to do to the graph if there's a negative there? It flips it upside down. So what you're going to have here, let's see. So cosine normally has like a maximum right here, right? So if you put a negative in front of it, it would flip it upside down. But there's no running out of time. Let's see. Yeah. So it has to be valid. I tell you what, because I'm running out of time, for the worksheet, it is posted on Canvas. You guys just write it down on paper. And the only thing I have to have for each graph is just the equation. Like the worksheet, let me show you up here. The worksheet is going to ask for vertical displacement, period, and B value, amplitude, reflection in the x-axis. So it asks you for all of those things. You do not have to answer those parts for me. I just want the equation. Okay, so just the equation for these graphs. And then I think there are a couple other questions down here. So just write it on paper. You only have to answer the equations for each graph. And then make sure you do the... And we still Okay, so sine looks like this whenever it has x or y intercept here, it goes up and then down. So what you are talking about having this thing go up and down, it also got the right
Okay, so cosine written down here.
Well, cosine, it has a maximum.
So for one,
So, cosine, you would have to take
for one,
cosine.
for one, you move it up the midline down.
You have to move it
So you can mark it
right
out.
or left, top, same
Then
difference.
from there, you can tell that it hits the midline on the y-axis.
It's not that.
There you go.
Normally we have to graph it like.
Well, go back. So you were saying, I think that
So,
would
you have to.
and it says like on the fly. So think both of them. I only put this side one here. Oh, yeah, I thought that.
This cosine. Yay, right?
So
But there
is
is another one that's.
another way to say that. Another way to say that is
What's that negative?
yes. It's not three
So
cosine.
we might take where you have
Do the
maximum.
thing. Cosine is plus 5. That's 5.
Does that make sense?
No, it's going to be either.
Yeah, I think you have to get it right. You got the midline is 3.
That's the other one.
And that's, yeah, so this would be regular sine, right? So it starts at the midline and it goes up and down. So this one right here would be all right. But so for the cosine, you would have
That's
the
also the
maximum
sine.
right here, right? And it would have to move to the right. This distance. How much is that?
I really don't know. It's still confusing to me. I know how so much we pick up pretty small.
Wait, wait, that maximum right there. How far is that out?
You don't. You don't see
None of
it.
those have.
Straight line completion.
So I think this.
So as long as you put it.
Is that the
She'll get it
sine
right there.
right there? Then you would. So like, you think about what you got right there. You have got is you've got this graph, you got the pie right here. And so it's maximum. Right there, that maximum. You have maximum here. So, if we want this graph, slide over to
I'm pretty sure. Oh, yeah, I see that. I did that. I know I did that. I'm pretty sure I did that.
this, right? So
No, you don't see that whole thing. It's just straight
so
up.
what we would have to do,
Well, oh, you got it. That's some of the right spots. I don't know that looks like signs like this, but that's the sign there. I don't know.
so,
It's
and
great.
we get to move higher. Now, I think that negative
Yeah, it's straight out completion. Go home and it's done. It goes up and down.
already out though, not what's over here, but where it is. So right here, imagine that. Yesterday on the so that is right. So that's why it's and here it is top. Two right there. Does that make sense? That one's your easiest. They're probably cosine that matches it. Yeah, how far would it have to go from right here over here? So half pi. I think I'll answer those to be right. I do have smart breakfast if you have any questions in the morning. Okay, that's right. Field trip tomorrow, so I don't need to count you absent. You will miss the unit circle quiz, so if you can just, I may just have to take it whenever you come back in, if you make it back in time. And then we will do those notes that I passed out yesterday. So I'll make sure I video for that. Okay. Yes, come during smart breaks. We'll just do it then. Yeah, that'll be even better. Where are you guys going? Okay.